And greetings to everybody all over the world. I think it's afternoon here, some may be in the morning, others in the evening. I also want to thank previous speakers, moderators, and reporters for the good work done, and to welcome you to the second session, that is the team 2, on data science and sustainable issues. Because we are far behind time, I will try and use less words. So we'll move on straight to the keynote speaker in the person of Professor Marwala, who is a professor in artificial intelligence and the Vice Chancellor and Principal of University of Johannesburg, South Africa. He'll be talking to us on closing the gap, the fourth industrial revolution in Africa. Prof Marwala, please, the floor is yours. Hello.
I hope you can all hear me. Thank you very much for the invitation, Professor Ojoko. I also would like to acknowledge the presence of many other distinguished speakers, Professor Ming Zhang, as well as my very great friend, Professor Fernando Buachi. We have been working together for a very, very long time, over 20 years now, ever since I was a postdoc at Imperial College. So I am going to just beam my presentation. Just one second. How do I do this? Can you see my presentation?
Yes, we can.
Thank you very much. I'm just trying to... Felix, it looks like my presentation is stuck. I don't know why. If you could just bear with me, I might have to just, okay. Then I will open it again. Yeah. So if I can just yeah, so thank you very much. I really wanted to talk about the fourth industrial revolution, artificial intelligence, data finance, and other applications. Of course, part of the reason why I've been quite interested in the fourth industrial revolution is because I think as the African continent, we have missed out on the first industrial revolution, where using the principles of physics and other sciences, England industrialized. I also think that in the second industrial revolution that gave us electricity and mass production of goods and services, it was also a missed opportunity. We have not been able to industrialize much of the African continent, with few exceptions. In South Africa, I think Rwanda now is doing quite well. And now we are in the third industrial age, the electronic age. In the entire continent, we still do not have a single large-scale semiconductor company. And as a result, we have not been able to build any form of an electronic industry. There's a little bit in South Africa, but it is not where it is supposed to be. Now we are living in the fourth industrial revolution, where production is going to be automated by artificial intelligence. I'm actually quite excited about the topic of artificial intelligence. Now, in the fourth industrial revolution is really about the confluence of several developments: AI, blockchain, quantum computing, Internet of Things, 3D printing, robotics, biotech, and the confluence of these technologies working together is what actually gives us the fourth industrial revolution. Now, one of the big technologies that is driving the fourth industrial revolution is really artificial intelligence. And I must confess, there's been quite a great deal of developments and confusions around artificial intelligence. Basically, artificial intelligence is the use of science to build machines that are intelligent. And there are many approaches that can be pursued. One approach is computational intelligence. Professor Fernando Buarque, I'm quite sure he would have spoken about computational intelligence. For example, in computational intelligence, you can use the swarming of birds to be able to build an optimization method that can be able to solve not very well defined optimization problems, even problems where your fitness function is not smooth. It might even include, and that is the question that Professor Fernando asked. In mathematics, they call it integer programming, where you are dealing with whole numbers rather than irrational numbers. In other words, if you are designing a shape of something, you want to find an optimal shape of, I don't know, maybe a car. That optimization is not going to be gradient based, because your fitness function, especially if it involves a concept such as a shape, would not necessarily be a continuous variable. It includes discontinuous variables. So computational intelligence, you have many other techniques that can be used in this regard. Genetic algorithm, fish school is another one. And then you have soft computing, fuzzy logic. This is the case when you do not have enough data to form probability distributions. Now, if you have enough data, you can be able to form probability distributions, and you can be able to do Bayesian analysis and so on and so forth. But if you do not have enough information, which is actually quite a big issue in the African continent, then you can use techniques such as fuzzy logic. Then you have machine learning, which is the use of data and statistics to build intelligent machines. And within the school of practice, these schools, whether it is machine learning, whether it's soft computing or computational intelligence, they don't quite get along. You know, for example, if you go to NIPS or NeurIPS or ICML, they won't be talking about genetic algorithm or fish school or fuzzy logic. And part of the reason is because they think the mathematics of soft computing is too soft for them. And when it comes to computational intelligence, they think these optimization techniques you cannot be able to mathematically prove convergence. And within machine learning, you will have deep learning, which is a very popular, contemporarily popular algorithm that has been developed over the last used over the last few years. It has been around for a long time. has just been used over the last few years. Now, this is how deep learning looks like. You will have a set of input, you will have a set of output. And it becomes deep learning because it has many, many layers. When I was a PhD student, many, many years ago, we were told that the idea of having multiple layers is not useful. I actually even still remember a statement that was uttered by Professor Buache, where he was saying that one of the incidences that misled him was to believe that the universal theory of approximation assertion that you can build a network with just one layer. And of course, if it is only one layer in between, it is not deep learning. We have found that having multiple layers actually give you advantages that that you wouldn't get if you have a single layer. So one of the problems that I have encountered, especially given the fact that I have worked almost all my professional life in the African continent, is that the African database is never really complete. And the data is never as reliable. And if you look at what is happening at the other end of the world, you will realize that all these algorithms that have been developed are developed under the assumption that data is complete. How do you build a system like this so that it can actually work even in the presence of incomplete information? I don't want to sound like a salesman, but me and a student of mine, Collins Leke from Cameroon, we wrote a book on deep learning with missing information. How can you still make decisions even when the information is missing? Now, this is an example of how we deal with issues of missing information. You create what is called an auto-associative network. This is almost like, sometimes it is called an auto-encoder. You basically train a network to remember what it has seen. Once you have trained this network, if you give it incomplete information, you can treat the incomplete part of the data vector as XU and the complete part as XK, because you already have an autoencoder. You are supposed to, the error between the output and the input is supposed to be as close to zero as possible. Then you can actually create a fitness function where the missing information here is actually a design variable, and you can use any optimization. You can even use gradient-based optimization, conjugate gradient, stochastic gradient methods to be able to solve for unknown variables. But of course, if it is an autoencoder, it will mean that you already have estimated your unknown variables. You can actually combine all this without even training it upfront, where you can use EM algorithm to be able to estimate the missing value as well as the network weight in order to impute missing information. And we have applied this to the HIV database in South Africa, the antenatal database. Of course, on the optimization side, here I'm talking about particle sum optimization. Or you can use, this is the work that I did with Adam Pantanovich, one of my students, where we were using a random forest to be able to do that optimization problem. Random forest is basically an ensemble of decision trees. And then here we were using hybrid positive selection algorithm in order to do the same problem. Now, I also wanted to talk about finance, because one area that is actually quite being impacted by artificial intelligence is the issue of finance. How much more time do I still have? Please, I don't want to run over. How many more minutes? Colleagues, are you there?
Yeah, please continue.
How many more minutes do I still have?
You have about 10 minutes more.
Okay, thank you very much. So you can be able to use AI for credit risk, portfolio optimization, financial forecasting, the issue of information asymmetry, market design, insurance risk. So basically this technique for machine learning and any other form of AI are now being used in the financial sector. This is an example of the work that we did with my student, Evan Hewitt, the role of artificial intelligence in reducing information asymmetry. Stiglitz won a Nobel Prize for coming up with the theory of information asymmetry. Basically, information asymmetry is a situation where you have two agents. One knows more information than another, information asymmetry. Now with AI, and this is the conclusion that we reached, you can actually be able to reduce the level of information asymmetry in your agents. And if these are trading agents, you can enhance the efficiency of that trade, and ultimately you will decrease the volume of trades, which is the negative aspect of this. This is another example of the work that we did on market efficiency and artificial intelligence, where we concluded that the more artificial intelligence you put into the markets, the more efficient your markets become. This is an example of the work that we did with on interstate conflict. Can you be able to build a machine learning system that would be able to tell if two countries are going to go to war or not? It turns out that we could be able to predict wars between two countries to the accuracy of over 80%, which is better than what political scientists are able to do. We wrote a book, Militarized Conflict Modeling Using Computational Intelligence. The Chinese defense press translated it into Mandarin. So as you can see, especially in the African continent, where conflicts are still something that we should be worried about, we should start using technology to try to solve these problems. This is an example of an application in detection of epilepsy from EEG signal. I mean, if you are using deep learning, you don't even need to do segmentation and feature extraction. You can be able to use raw data as it is, especially if you have millions of this. But if you have limited amount of data, then you have to go back to the issue of data analysis, time frequency analysis, wavelengths, and so on and so forth. Something that people in machine learning now are forgetting about the concept of signal processing, simply because deep learning are able to handle this through their convolution characteristics. This is another example, pulmonary embolism detection. Here we're using support vector machines. People have forgotten about support vector machines. They are very good at classification, especially single two-class classification. And we're able to detect pulmonary embolism to the accuracy of almost 98%. This is another example of the work that we did here. Is somebody who lost their voice box, but they can still move their tongue. Normally you lose because of cancer. So you put this device that we design inside the mouth, and then once somebody is speaking, the movement of the tongue is translated into data. The data is put into a deep learning neural network, and you are able to synthesize the speech. And you can even use GANs here in order to synthesize the speech, the lost speech, in the exact voice of the person that you are trying to help. We have a US patent on this, and this work was actually featured at MIT Technology Review many years ago. This is another example of the work that we did. Here we're using neural networks. We design it to play poker game. Of course, now, you know, I mean, AlphaGo is able to play a much more complicated version of chess, Chinese chess called Go. But here we're just designing it to play poker, and it will play until it is very, very well. What we observed out of this is that it actually learns how to bluff on its own. Bluffing is very, very important in the playing of poker. And this work was featured in the New Scientist. I was going back. And then this is another work that we did. Here we were designing a system that to arrange patients when they come to casualty wards. And user input, patient data, Q, reinforcement learning, genetic algorithm. Ultimately, you actually get who should be helped first, second, third, and fourth, depending on the conditions. Without actually the much human interaction, is basically genetic algorithm and reinforcement learning. And the data that is input that will allow you to cue who is going to be helped when, you know. Finally, closing the gap, I think as Africans, we need to invest in human capacity development. I think we need to be teaching people in the African continent on technologies of the fourth industrial revolution, blockchain. I'm glad that one of my students, Shakir Mohammed, has established the deep learning Indaba that is teaching machine learning throughout the 33 African countries. Very, very important that we need to build capacity. You know, we need to have more people moving within our universities here at the University of Johannesburg. I would like to host some of you to come and spend some time. I've hosted Professor Fernando. He has come and spent some time here. I would like to also welcome some of you to come and spend some time so that we can work together. I think we need to invest in artificial intelligence. The African Union is investing into AI forum. We need to be involved. I think we need to deal with issues of data protection. How do we protect African data? How do we collect it? How does the African Union comes into the picture? Where should we establish our own data centers, or should we buy clouds? How about cloud computing? All those issues are very, very important. We need to incentivize our people to be able to invest in these technologies. We need to look at our laws so that they facilitate the adoption of these technologies. So thank you very much. I hope I did not take more time than you have assigned to me. I thank you very much.